Answer the following. You can shield a charge from electrical forces by putting it inside a hollow conductor. Can you shield a body from the gravitational influence of nearby matter by putting it inside a hollow sphere or by some other means? We cannot shield the body from the gravitational influence by any means. In case of electrical charges, if we place a test charge Q inside a hollow conductor, let's say this is the hollow conductor, and we have brought a charge Q near to it. So in this case, there is going to be an induced charge on the surface. And due to this induced charge, the net electric force on this test charge is going to be 0. Whereas in case of gravitation, no such induced effects occur. So therefore, we cannot shield the body from the gravitational influence by any means. Let's look at part B of the question. An astronaut inside a small spaceship orbiting around the Earth cannot detect the gravity. If the space station orbiting around the Earth has large size, can we hope to detect the gravity? So in part B, it is said that initially the astronaut is in a small spaceship. The forces acting on the astronaut will be the gravitational force due to the Earth and the pseudo force or the centrifugal force Fc. As the spaceship is revolving in a circular orbit, these two are going to cancel each other and the net force on this astronaut is going to be 0. So due to this, he is not able to measure the gravity. Whereas when the spaceship is larger, let's say this is the largest spaceship, the gravitational force at different locations is going to be different. So the gravitational force at this point will not be equal to the gravitational force at this point or at this point. So every point inside the spaceship is going to have a unique gravitational force. So when the spaceship is large, he is able to measure the variation of the gravitational force. So in part B of the question, yes, we can hope that he can detect the gravity. Look at part C of the question. If you compare the gravitational force on the Earth due to the Sun to that due to the Moon, you would find that Sun's pull is greater than that of the Moon's pull. However, the tidal effect of the Moon's pull is greater than that of the tidal effect of Sun. Why? The tidal effect acting on the Earth is proportional to 1 by r cube, unlike the gravitational force, which is proportional to 1 by r squared. Though the gravitational force due to the Sun on the Earth is greater, the tidal effect due to the Moon would be greater because the distance between Earth to Moon is less than, or it is very less than, the distance between Earth and the Sun. So 1 by r cube term is going to dominate over 1 by r squared, and this is the reason why we have the tidal effect of Moon dominates that of Sun.